Everyone, Mr. Smith here, and in this video lesson, we are going to learn what a function is. Before that, if you could smash that subscribe button. I'm just kidding. I just always wanted to say that. You can subscribe if you want to, but this channel is not being monetized or anything. This is just recording videos to make my life easier teaching you guys this semester. But let's get into it. We're going to talk about what a function is. Should be good. So earlier, we reviewed what a relation is, and we looked at many different types of relations. We looked at a linear relation, a quadratic relation, and then we looked at some new relations as well. But this course is called functions. So we want to talk about what it means for a relation to be a function. So the whole point of this lesson here is just to get a working knowledge of what is a function. So what I'd like to do is, before actually just telling you, like, this is the definition of a function, I'm going to give you some examples and non-examples. So here, and on your lesson sheet there, I've given you two relations. So I've given you the equation and the graph of these relations. One of these is a function. Relation A is a function. Relation B is not a function. And I've given you guys a table as well. That's on my next slide. And I want you just to complete the table. You have the graphs. You also have the equations, but you have the graphs. You can just pick off the points, and hopefully we'll start to make a connection about what makes a relation A a function and what makes relation B not a function. So if we look at relation A, I mean, it's the basic parabola. So ideally you have these points memorized, but you can see when x is minus 2, the y value is 4. When x is minus 1, the y value is 1. When x is 0, the y value is 0. And so on and so forth. The final two y values, 1 and 4. That looks like a backwards G. That looks like my son Asher, who's 3, was trying to write a G. We'll make that a 0. All right, the next one, not so simple. So when x is 0, here's the point, okay, and it's just 1 point, y is 0. But what about when x is equal to 1? When x is equal to 1, there's 2 points, right? There's the point 1, 1, but also 1 minus 1. So maybe we'll write it this way. When x is 1, y is 1 or minus 1. When x is 4, the y value, there's 2 of them, right? There's 4, 2 and 4 minus 2. Those are both on the graph. So 2 or minus 2. And then hopefully you get the idea. It's the same for any value, but I chose ones to give you nice whole numbers. For 9 and for x equals 16 as well, you get 2 values on the graph. 3 or minus 3, 4 or minus 4. So relation A is a function. Relation B is not a function. And so maybe in your mind, you're starting to see a difference between the two. Let's look at another example, non-example, and then make a connection, describe what a function is formally. So in relation B, so when x is 4 or any other value, we had 2 of those points. Where are these points relative to each other? Like, how would you describe it? If you want to pause the video and just think, for these 2 points, I'm going to circle right here. How would you describe their position related to each other? So if you said they're above one another, that's pretty good. Or maybe they form a vertical line, or they're stacked on top of each other. But that's the idea, is those 2 points when x equals 4 are along the same vertical line. Let's look at another example, non-example. So the relations we looked at in our previous lesson, they were all of the form, I might just get a different color here to scribble in the margins here. They were all in the form y equals, right? And so the rule was to get the y values, you do this on your calculator and it spits out the x values. But as you guys have actually seen in your grades 9 and 10 courses, that relations don't have to be in that form. For example, look at relation C here. The equation describing this relation is x plus y equals 5. So in words, that is saying that for this relation, the x and the y values have to add to 5. And if you look at all the points on this graph, so like say take 0, 5, for example, 0 plus 5 is 5. Or 3, 2. 3 plus 2 is 5. Or even a point like 6, negative 1. 6 plus negative 1 is 5. Everywhere along that line, the x and y value adds to 5. So our relation doesn't have to be in y equals form. Relation B is the equation of a circle. And hopefully you touched on those last year. I will tell you we don't really do much with equations of circles. So if you didn't really get to that or spend a lot of time on it, don't worry about it. Just you can take my word for it that if you look at all the points that satisfy this equation, where the square of x plus the square of y gives you 25, it makes a graph like this. So for example, a point like 5, 0, that's on the circle because 5 squared is 25 and 0 squared is 0, and those add to 25. A point like 4, 3 is also on the circle because 4 squared is 16, 3 squared is 9, and those add to 25 too. So again, you just have to take my word for it if you didn't get to this last year, that this equation gives you this graph. Relation C is a function. That I guess should be relation D, is not a function. And let's complete a table here to kind of maybe make some connections to the previous one. So just as before we do this one, I'm in the building right now just shooting lessons. Maintenance is happening. People are walking in the room. So we just got to roll with it. It is what it is. Again, my editing team is me, and I don't edit my videos afterwards. So we just shoot and post. So minus 3, 8. Note those add to 5. Minus 2, 7. Minus 1, 6. You kind of see the idea. And again, all those points do add to 5. They all satisfy the relation. But like for one x value, there was one y value, right? But look at the next one for relation D. When x is minus 5, you get one y value, 0. And the same thing I'll say for when x is 5, there's one y value. It's the 0.50. But anywhere else, so like when x is minus 4, there's actually 2 points on the graph when x is minus 4. There's minus 3 or 3, and for minus 3, you get 4 and minus 4, or minus 4 and 4. For 0, you get 2 points, 5 and negative 5 and 5. And then you get the same ones for 3, and the same ones you got above for negative 4, you get for positive 4. So for this function, for this relation that's not a function, some x values had multiple y values. They're stacked on top of each other, right? So we're now beginning to see a picture of what makes a relation a function and what makes one not a function. So we can kind of see for the examples that were functions, one x value, one y value. X value, y value. For non-functions, sometimes an x value has multiple y values stacked on top of each other. So we're getting closer to actually saying what a function is. For the last example, or maybe even do for all 4 of them, take your pencil or whatever you're using and just move it along the graph like so. And think about what happens when you do it for B and D. What happens when you move your pencil across A and C, the ones that are functions and the ones that are B and D? This brings us to a test that we can actually use to determine if a function or a relation is a function or not. So I'm going to state the test and go back and look how it works for our previous 2 guys. So the vertical line test says this. If you take a vertical line and it intersects your relation more than once, at more than one point, the relation is not a function. So if we go back and look at our relations A and B, let's say, so for the relation y equals x squared, if you took a pen or a pencil and just crossed over that with any vertical line I draw on this graph only ever touches it one time, right? So that is a function. But relation B, at 0, yeah, I only touched it one time. But anywhere else, and even below 0, you're touching it no times. That's okay. But if you're touching the graph more than once, it's not a function. So functions have, when you plug in an x value, you get a y value, a single y value. You don't get multiple ones. The graph, we say, fails a vertical line test if it's not a function. C and D, same thing. If you pass along this line with a vertical line, you only ever hit it one time. But for the circle, sometimes you hit it no times. Sometimes you hit it once, like at -5 or 5. But in the middle of the circle, you're hitting a vertical line passes through it twice. So that's the idea. If for a function, you only ever pass it one time with a vertical line. Every x value has one y value, not like our circle that sometimes has two y values. So that brings us to, we've got the vertical line test down. Well, actually, you know what? Before we get a definition of a function, can you just try applying the vertical line test to these three relations? These are three relations I've just made in a graphing program. Can you apply the vertical line test? And it's a simple yes or no. Are they functions or are they not functions? Do they pass a vertical line test or do they fail the vertical line test? So you want to pause the video, take a little moment, shouldn't take too long. What do you think? You can unpause when you're ready. All right, here we go. So if you said this guy was a function, good for you. If you pass a vertical line along this guy, you'll only ever hit it one time. However, the graph in B is not a function because on the right side here, for these positive x values, a vertical line would hit it twice. That's no good. For C, I would expect some of you to actually say it's not a function, but it is. Because if you pass a vertical line along this graph, you only ever hit it one time. It's a vertical line test. It's not a horizontal line test. Sure, if you pass a horizontal line, the graph would hit a horizontal line more than one time, but that's not what the test for a function is. It's a vertical line test, and the graph in C passes it. So what is a function? A function is a special type of relation in which each x value corresponds to exactly one y value, which means if you had the equation, let's say, you plug in an x value and it gives you one y value. You never have multiple points stacked on top of each other. So that's what a function is. And so the nice thing about this is you've been working with functions already in grade 9 and 10. In grade 9, most of your lines that you worked with were functions. We just said, hey, you guys are doing linear relations, when actually you were studying linear functions. And in grade 10, when you guys were studying quadratic relations, you were actually studying quadratic functions. Now, as one interesting aside, can I do lines here? No, ooh, don't do that. Can I make, I can make arrow option. Okay, I shouldn't do this when I'm doing a live lesson. But I want you guys maybe think about this. Are all lines functions? Or can you graph an example of a line that doesn't pass the vertical line test? And it's really interesting. So where's my pen? Oh, I just changed it to a weird color. Yeah. So, here's a regular line, and that one passes the vertical line test. A line going back this way would pass the vertical line test. Even a horizontal line would pass a vertical line test. But there's one type of line that actually doesn't, and those are vertical lines. So not every line is actually a function. A vertical line would not pass the vertical line test because at that one point, you're hitting the line everywhere. But all parabolas are functions. Any quadratic relation is a function. But with a parabola is just, they are what they are. They're open up or open down. There's no funny business. Every single parabola you can draw will pass a vertical line test. And if you're wondering what about the previous example we had, the sideways parabola, that's not technically a parabola since it's opening sideways. All right, so we've established what a function is. Function passes a vertical line test. X values have exactly one y value. So let's just do a couple of examples. And this is also just reinforcing the skill of creating a table and a graph. And it's also actually just looking at some interesting types of functions that we might look at this year. So the first is y equals x to the power of 3. So this is a cubic relation. And we are interested in knowing, can we call it a cubic function, or is it just a relation? So to investigate, let's make a table of values and make a sketch and see what we get. So I've left the x values blank here. You can choose whatever x values you want, but often it's practical just to choose some symmetric values about 0. So let's choose these guys. And we are cubing these values. So -3 cubed, that's -3 times -3 times -3. Or you have your cube button on your calculator. So some of you guys will have just a cubed button, like x cubed. Some of you guys might have to use your exponent button, and then tell it to do 3. So that could look like x to the power of y, or y to the power of x, or maybe a little chevron like that. If you need help working with your calculator, again, you guys are with me during our class time. So definitely, call me over, or let me know in the virtual classroom, and we'll easily figure that out. But yeah, let's slam these in. So we get this actually gives you -27, and that doesn't fit on the graph, but that's okay. -2 to the power of 3 is -8. Now we can get negative values because we are multiplying these by an odd number of times. We get -1, 0 cubed is 0, and then you just get the positive counterparts on the other side. So plotting the points we can, -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. We get a cool looking graph. Now it almost looks like half of a parabola opening down, and then another half of a parabola opening up. Now, I'll ask you guys, maybe you can quickly think. We've made the table, made a graph. Is this relation a function? And the answer is yes. It passes the vertical line test. It's a function. When you plug in an x value, this just gives you your calculator. It doesn't do any funny business. It just gives you a y value, right? This is a function, passes the vertical line test. Plug in an x value, you get out exactly one y value. This is called the cubic function. And we don't actually spend a unit working with the cubic function, but we might sketch it and do transformations of it later on. But yeah, that's a cubic function. That's pretty neat. And I believe we're doing one more. I think we're doing one more. We are. This is the last one. So here we have the relation, the equation anyway, looking a little different. Here I've given the equation in terms of x. To get the x values, you square the y value and subtract 1. So for this one, it makes sense for us to actually pick some values for the y values and then see what we get for the x values. This is not how you must do it, but I think it's practical and it makes sense for me to do it this way. So using this rule, maybe I'll show my work for the first couple. To get the x value, this rule saying is we square the y value and subtract 1. That's 9 minus 1, that's 8. And then -2 squared is 4. 4 subtract 1 is 3. So if you want to generate the last one, you can pause the video, unpause when you're ready. Or if you want to follow along with me, that's fine. We get 1 minus 1 is 0. 0 minus 1 is -1. 1 minus, and then it's symmetric. Yeah, 0, 3, 8. So, the nice thing about what we're doing with this flipped classroom is, you have the flexibility to pause and reflect whenever you want, and you're not going to miss anything with me rushing forward. So make use of that. And also you can rush forward too. If you get it, you can, just keep moving forward. You're just checking in to make sure you're good. But yeah, you have that flexibility too. So that's great. Let's plot those points we have. So 8, -3, 3, -2, Just being careful here. 8, -3, 3, -2, 0, -1, -1, 0, 0, 1. All right, so alarm bells went off for me as soon as I plotted that point 0, 1, and hopefully they did for you too. So this is another one of those kind of sideways parabola guys. Is this relation a function? Nope. It fails a vertical line test. Everywhere above -1, a vertical line is going to pass through more than one point. So this is a big no. It fails a vertical line test. So what should you guys know after this lesson? You should know how to apply the vertical line test to see if a graph is a function or not. And you should also know the definition of a function. Every x value corresponds to one y value. So not exactly a heavy lesson, introducing what a function is. What are we doing in our next lesson? So sometimes, as we've seen, especially in our very first lesson on relations in the rule of 4, certain x values aren't allowed to be put in a function. It kind of breaks the equation, right? So remember, if you remember y equals root x, we couldn't put negative numbers in there because the root of a negative number gave us an error on our calculator. Or even if you think of, remember 6 divided by x, you couldn't put 0 in there because it kind of breaks down. You can't do 6 divided by 0. And then some functions only give you certain y values at the other end. So for example, the basic parabola, remember the basic parabola just opens up like that. You only ever get y values that are positive or 0. You can't get a negative value for y equals x squared. But then when we graphed the cubic function, we got negative numbers and 0 and positive numbers. So what we need to be able to do is begin to describe, well, given a function here, what numbers am I allowed to plug in? And what numbers can come out? So we want to discuss those things in our next lesson. I will save it for then. But until that time, hope you guys are staying well. Have a great day, and we'll see you soon.